4.2 Exponential Functions. In this section, I want you to be able to solve an exponential equation. Okay? So we're going to start with our first example. 4 to the x power equals 2. Now, the easiest way for me to explain how to solve for x is by knowing your 4 and 2 are base numbers. They're the big numbers. They're base numbers. X is in the exponent place. So in order to solve this, I need my bases to be equal. They need to be the same number. So I'm going to write them as a number that I can raise to a power. For instance, I know I'm dealing with 4 and 2. So the lowest form I can write, my 4 would be 2. I know that I can raise 2 to the second power and it would give me a 4. I'm going to end up writing my base numbers in base and exponent form in order to get an actual number. So let me say that again. Between 4 and 2, I know my lowest number I can go is 2. So I'm going to take the left side and I'm going to say 2 to the second power. That is 4. You want to make sure you make it equivalent to the number that's in the base. Now, there's an x that's on the left side as an exponent. I bring it down. On my right side, I didn't do any change. In order for me to stay a 2, I would technically be raising that to the first power. Because what's 2 to the first power? It's 2. There's no change. So once I have my bases equal to the same number, I have raised my exponent to be the number that will give me my previous base. I set the exponent part equal. That's how I solve. I'm going to set 2x equal to 1. And we know that x is 1/2. And that's my answer. That's what I'm looking for. What is x? X is 1/2. Let me show a second example. Hopefully that it will click a little better. 125 to the x power equals 5. 125 to the x power equals 5. So when I look at 125 and 5, the lowest base I can write would be in terms of 5. Okay? Now, if you need to pull out your table, your chart, pull it out because it will help you see your exponents. If you don't know 5 to the third power is 125. I would need to raise 5 to the third power in order to get 125. Okay? If you look at your chart and you go to 125 under the perfect cube column, you would see, and take your finger over to number, you would see 5. Do you see that? Or you can go backwards and go under the number column to 5 and see 125 in the row and look up and you'll know what exponents you got to use. It says perfect cube, so that means I need a 3. There's an x already on the left side. And then I look at my right side. Did I do any change? In order for me to stay 5, I would need to raise it to the first power. 5 to the first power is 5. And then I just set my exponents equal to one another. 3x equals 1. You divide by 3. X is 1/3. Third example. 5 to the 2x plus 1 power equals 25. So look at our base numbers. We have 5 and 25. So I would hope that you see that the base needs to be written in terms of 5. Okay? Now this time on the left side, I'm at 5. There's no change that needs to be made. Now I can raise 5 to the first, but what would 1 times this stuff be? Just that stuff. So this case, since there's some stuff already on the left side, I really don't need that 1. So I'm just going to bring down the 2x plus 1. That's my exponent. Now on the right side this time, there's the 25. So I would need to raise 5 to the second power in order to get 25. Does that make sense? This is what I'm trying to do. I would need to raise 5 to the second to get 25. So now I'm going to set both exponents equal. 2x plus 1 equals 2. And I'm going to solve for x. I'm going to subtract 1 from 2. That will leave me with 1. Divide by 2. X is 1/2. Let's look at another one. What if we were to have 7 to the 3x minus 1 power equals 49? Well, hopefully you can see that if I got 7 and 49 as bases, then the lowest I can write them both in is in terms of 7. So on the left side, there's no change from here to here. In order for me to stay 7, I'm just going to raise it to the first. So I'm just going to bring down my 3x minus 1 as the exponent. And then on the right side, in order to get 49, I'm going to raise 7 to the second power, because 7 times 7 is 49. And then you just set your exponents equal to one another. 3x minus 1 equals 2. So I'm going to add 1 to my 2. That will give us 3. Divide by 3. X equals 1. Two to the 6 minus 3x power equals 8 to the x plus 1 power. So we have 2 and 8. So we're going to use base of 2. And again, on the left side, 2 to 2 is no change. So I just bring down that exponent. However, on the right side, I would need to raise 2 to the third power in order to get 8. In order to get 8, I would need 2 to the third power. Now be mindful, there is an exponent on this side that's x plus 1. And do you see I put it in parentheses? Because you're going to have to do distributive property with that 3. Okay? So I put it in parentheses so you know to distribute. And I'm going to set them equal. So I have 6 minus 3x equals 3x plus 3. When you do distributive property, 3x plus 3. So I'm going to put my variables together. So minus 3x, put my whole numbers together, 3 minus 6. So that would give me a negative 6x equals negative 3. Divide by negative 6. X equals 1/2. When you reduce, that's 1/2. We were to have 27 to the 4x power equals 9 to the x plus 1 power. So with 9 and 27, I would hope that you could see that the lowest I can go is 3. Now, it wouldn't be 9, because keep in mind, 9 to the second power is 81. I'm way bigger than my 27. So I have to think a little harder that 27 and 9 both have that common factor of 3. That's the lowest number. It's going to be 3. So that's my base. Now on this one, I'm showing you that I'm going to have to raise both sides to an exponent in order for me to get 9 and 27. Okay? So I want to show you one like this. So on the left side, in order for me to get 27, I would need to raise 3 to the third power. 3 to the third power is 27. Now I'm putting in parentheses the 4x because it's already on that side. On my right side, I would need to raise 3 in order to get 9 to the second power. 3 times 3 is 9. And I'm putting in parentheses the x plus 1 because it's already on that side. And then you're going to set the exponent part equal. So this is just multiplication. 3 times 4x is 12x equals, you're going to distribute the 2. That will give me 2x plus 2. So I'm going to solve for x, put my x's together. 12x minus 2x equals 2. That will give us 10x equals 2. We're going to divide by 10. And we're going to reduce. 2 over 10 reduces to 1/5. So x is 1 over 5. We have on number 7, 9 to the 3x minus 1 equals 81 to the x plus 3. So you can use one or two numbers. You can use 9, or you also can go farther and use 3. 3 is a common factor that you can use, that you can raise to get your actual 81 and 9. But I'm going to use 9. So that means by using 9, I don't have to change my left side. I'm just going to bring down the 3x minus 1. And then on my right side, to get 81, we're going to raise 9 to the second power. And then in parentheses, there's an x plus 3 as an exponent already on this side. So since they are equal, my bases, I set my exponents equal. So I have 3x minus 1 equals 2x plus 6. Make sure you're reminded to distribute the 2. So we have 3x minus 2x equals 6 plus 1. When you switch sides, that will leave us with x equals 7 as our answer. And number 8, 2/3 to the x power equals 9/4. Now, I don't really want to set this up as equal bases. I want you to kind of think a little bit. Now, if I look at 2/3, I need to raise it to some number that's going to equal 9/4. So I'm thinking, now 2 doesn't go with 9 and 3 don't go with 4. 2 goes with 4 and 3 goes with 9, if you can see that. So I need to think, if I'm given 2/3, how do I get a 9 and a 4? Well, obviously, I would need to raise 2 and 3 to the second power. If I do that, 2 to the second power is 4. 3 to the second power is 9. Now, I get the numbers, but they're in the wrong spot, according to the problem. So how would I make these numbers flip? Okay? Keep in mind, we talk about flipping, moving. This goes back to we talked about exponents. That means that the exponent must be negative. That's the only way it can be flipped. Okay? So if those 2's were negative, and I'm going to write it in red over here, that would mean that 3 to the second would have to come to the top, and 2 to the second would have to go to the bottom. You remember we said you got to move negative exponents. And that way, 3 to the second is 9, and 2 to the second is 4. That way, it will match. So, what is x? Well, x has to be a negative 2. And that's just thinking without me having to write out or actual how to get it. My numbers are in the wrong spot. So in order for me to move, to flip, I have to have a negative exponent in order to do that. So my answer would be negative 2. This concludes for 2.